Hi friends, I am Viraj and let's start with a video series on shell scripting. Shell scripting is widely used in Linux for automating many different tasks. So let's dive into shell scripting. So before I start with the shell scripting, let's start with the simple Linux commands that we normally use, and then we'll dive into automating all these tasks. Okay, so suppose we want to create a directory on a Linux file system. So how do we do that? To create a new directory, the command that we use is mkdir and give the folder name. So in this command, what I've done is I'm creating a new directory whose name is new underscore folder. So as soon as I say mkdir new folder, it will create a new folder on your Linux file system. Now that we have created a folder, suppose I want to delete that folder. Then to delete, the command in Linux is rmdir, that is remove the directory and give the directory name. So it will remove the directory new folder. Now we have seen how to create a directory and how to delete a directory. Now let's see how to create a new file on Linux file system. So we can use touch command, touch followed by a file name. Okay, so using touch command, it creates so and so file on your Linux file system. Now that we have created a new file, let's see how to delete that file from Linux file system. So the command that we use is rm. So rm followed by name of the file which we need to delete. Okay. Next is, suppose you have created a new folder and inside that folder you have created more directories and more files. Okay. So there is a folder that you have created and in that you have many files and folders nested into that. And what if I want to delete the contents of the entire folder, wherein I want to delete all the files and folders which are there in my current folder? That is, I want to do a remove operation in a nested fashion. How to do that? For that, the command is rm-rf. R is recursive and F is forced deletion. Okay, so F meaning it won't prompt the user for any confirmation. It will forcefully delete the files. And R means recursive. That means for this folder, it recursively deletes all the subfolders and files in that. Okay, so using rm-rf, and when you give a folder name, it deletes all the files and folders which are there in this particular folder. Clear? Now we have already seen in Linux how to copy a file, right? So how do you copy a file? Using a cp command. So using cp, you need to give the source file and you need to give the destination path. So it copies the source file to destination file. Okay, but in Linux there are some folders which needs the root access, okay, or a sudo access. So you need to have a sudo privilege in order to place a file at a particular location. You don't have a write permissions in that. Okay, so here in this example I am copying so and so file at /user local bin, but as a normal user I am not allowed to copy a file to /user local bin. So how to go about that? For that you need to use a sudo before your command. Okay, and you as a user need to have a sudo privilege in order to execute that command. So the command goes sudo copy, that is cp, source file to destination path. So it copies so and so file at /usr local bin. Clear? So here the sudo is mandatory because a normal user don't have the right access to /usr local bin. So using sudo, I'm impersonating the root access. So I'm saying sudo followed by the command. And what is the command here? cp source file to destination path. So again I'll repeat, in order to copy a file at /usr local bin, as a normal user you need to do a sudo. So sudo cp source file to destination path. Clear? Now suppose I want a folder to be copied at some target location, and I want that folder to be copied in a nested fashion. That is, suppose there is a folder, and inside that folder there are many files and subfolders. I want to copy the entire folder along with its files and subfolders to a target location. For that I need to use -r. R is recursive. So cp is the command, -r means recursively copy the source folder to target path. Is that clear? So using cp-r, I am copying recursively all the contents of the source folder into target location. Is that clear? So using cp-r, I am recursively copying all the contents of the source folder to target location. So this is how to copy a folder to a target location recursively. It will copy all its subfolders and files inside that. Clear? Next is how to move a file on a Linux file system. Suppose there is a file whose name is old file. I want to move that to a new name, or we can also say that I want to rename this file to a new name. So how to do that? And mv is the command, mv old file name space new file name. So with this what will happen is, it will rename a file on a Linux file system whose name was old file to a new file. So using mv command, we are moving this old file to a new file. That means it is as good as I am renaming the file from its name old file to its new name, that is new underscore file. Clear? Next is a top command. Suppose you want to know the current usage of the system. Okay, how much of the RAM, how much of the CPU is being consumed. For that you need to use a top command. It will give you statistics of the different processors, capacity utilization, RAM capacity utilization, and many other parameters. Suppose you want to list all the USB devices on your system and its details. So the command is ls usb. So with this you will get the USB related information on your Linux file system. Next is lspci. lspci means it will list the PCI related information on your Linux system. ipaddr is a command for networking information. Okay. Now we are moving on to very important command in Linux, that is chmod. Okay. Remember one thing, for any file on a Linux file system, its access is being clubbed by three important groups. Suppose I have a file on a Linux file system whose name is test file. So when you use ls-l and a file name, it gives you details of that file. Okay, so there is a hyphen here. Can you all see this? So this hyphen will detect whether this particular file is a directory or it's a file. I repeat, the first bit that you see here, you can see here hyphen, right? So this particular bit indicates whether this particular entity is a file or a directory. This hyphen means it's a file. Suppose this entity was a directory, in place of this hyphen it would have a letter small d. I repeat, If this particular entity was a directory, in place of a hyphen, we would have noticed small d. So hyphen means this particular entity is a file, it's not a directory. Next 3 bits are meant for user or the owner of the file. Okay, so these first 3 bits are reserved for owner of the file. So what are these 3 bits? First bit is read, second bit is write, third bit is execute. I repeat, first bit is read, second bit is write, third bit is execute. So what does this means? All 3 bits are set for this particular file. It means this particular file have a read access, it has a write access, and it has a execute permissions for owner of the file. Why owner? Because the first 3 bits which I have mentioned here are meant for owner of the file. So read, write and execute, all 3 bits are set for this particular file. That means the owner of the file have read, write and execute, all 3 permissions. Clear? Next 3 bits are for the group to which the owner of the file belongs to. I repeat, next 3 bit belongs to the group to which the owner of the file belongs to. So here also read, write and execute, all 3 bits are set for this particular file. It means even the people who are in the same group as the owner of the file can have read, write and execute permissions on this file. So suppose there is another user who is also in the same group as the owner of the file, even that user will have read, write and execute permissions on this file. And last 3 bits are meant for any other user on the Linux file system, any other user. Okay, so for that user also we have read, write and execute permissions. So just to iterate or summarize, first 3 bits are meant for owner of the file. Next 3 bits are meant for the group to which the owner of the file belongs to. And last 3 bits are meant for any other user on your Linux file system. So looking at these bits carefully, the owner of the file have read, write, execute. Any other user which falls in the same group as the owner of the file also have read, write and execute permissions. And any other user on your Linux system which is also not belonging to the group to which the owner belongs, so even those users have read, write and execute permissions on this file. Okay, so these particular permissions are also represented in numeric format. So let's learn how to do that. Remember, any particular bit can have that bit set or unset. I repeat, any bit in this particular permission access can either have a permission or not have a permission. So in short, either this bit can be read or no read. This can be write or no write. This can be execute or no execute. Correct? That means any particular bit can have only 2 values, either a 0 or a 1. Clear? Any bit can have only 2 values, either 0 or 1. So let's consider that having this particular permission at this bit means value 1 and not having a permission value 0. So in this example, the owner of the file have read, write and execute. Correct? So which is as good as saying 1, 1, 1. So in binary, 3 ones means value 7. Right? Now next move on to the group to which the owner of the file belongs to. What are the permissions which are allocated? Read, write and execute. So 1, 1 and 1. So in binary, 3 ones mean value 7. And next 3 bits are meant for any other user on the Linux file system. For that again we have a 1, 1 and 1 which is a value 7 in binary. Okay, decimal value 7 for a binary combination 3 ones. So for this file we have a value 7, 7, 7. So when any particular file has a permission 777, it means the owner of the file can have read, write, execute. The group to which the owner of the file belongs to can also have read, write, execute. And any other user on the Linux file system can also have read, write, execute. So please remember this 777 permissions to a file is a very dangerous permission setting, because any other user will be able to read, write and execute that particular file. Okay, so you should always try to keep the permissions of the file restricted to the owner of the file, the group to which the owner belongs to, and the least permission should be allowed to any other user. Depends on your application. So normally any other users on the file are max given read permissions. Okay. So chmod is a command using which we can change the permissions of any particular file. So chmod, O means any other user on the file system, plus means I am adding these permissions to this file. So what are the permissions that I am adding? Write and execute. So for so and so file, I am saying for any other user on your Linux file system, please add write and execute permissions to it, to any other user. So chmod, file name, and to any other user on the file system, which is the last 3 bits, please add write and execute permissions. Write and execute permissions. And that is the meaning of this chmod command. Let's have more examples on chmod. Here I am doing a chmod on so and so file. U means the owner, the user owner of the file system. O is the owner and U is any other user. Okay, so chmod, file name, U is any other user on your Linux file system. So I am saying minus means remove that permission. So for any other, so in this chmod, what I am doing is, whoever is the owner of the file, I am removing its execute permissions. So minus meaning remove, plus meaning add. Okay, so for the owner of this particular file, I am removing its execute permissions. So execute permission which was set for this file, I am removing it. So if you have noticed here carefully that X letter which was there at execute permissions, it has been gone away from here, right? So plus meaning add, write and execute to any other user on the file system. So the first 3 bits are for the owner, next 3 bits are for the group to which the owner belongs to, and the last 3 bits are for any other user on your file system. So with this command, what we are doing is we are adding write and execute permissions to the other user. So the last 3 bits are meant for other users. I am adding write and execute to it. With this command I am saying please remove the execute permissions to the owner of the file. You meaning owner of the file. So from this owner I am removing the execute permissions. In place of X, it has been replaced with hyphen now. That means the owner of the file going ahead won't be able to execute this particular file. We are removing the execute permissions for owner of the file. So is chmod clear? The first 3 bits are meant for the owner. Next 3 bits are meant for the group to which owner belongs. Last 3 bits are meant for any other user. In this command, I am saying for any other user, add write and execute permissions. In this command, I am saying for the owner of the file, remove its execute permissions. So the execute permission which was set earlier is being removed now. Clear? Now let's continue with more examples on chmod. What am I doing here? G stands for the group. Can you all tell me which are the 3 bits which belongs to the group? The next 3 bits, right? So in this command, what we are doing is for a test file, we are assigning so and so permissions to the group to which this file belongs to. Okay, so I am saying read, don't give write, and give a execute permissions. I am using a equal to sign here. Equal to sign means whatever permissions are mentioned here, please assign those permissions for this particular group. Okay, so I am saying give read, don't give write, and give execute permissions. I repeat, I am saying give read, don't give write, and give execute permissions to so and so file, and give this particular permissions to the group to which this file belongs to. So after I do a chmod, ls-l will list the details of test file. So if you notice here carefully, to the group I am saying read, don't give write, and give execute. So give read, don't give write, and give execute permission. Simple. So the first 3 bits are meant for owner, next 3 bits are meant for a group. That's why these 3 permissions which we assign here to the group are reflected here, because these 3 bits, second set of 3 bits are meant for the group. So r minus x is exactly mentioned here. Okay, let's discuss more on this. What am I doing here? I am saying to any other user on the file system, add write and execute permissions. So the last 3 bits are meant for any other user. So I am giving write and execute permissions. I am adding it. Write and execute permissions. Then I am saying for the owner of the file, remove its execute permissions. So the first 3 bits are meant for owner, right? So I am removing its execute permissions. That's why this X have gone away. Next I am saying to the group, you assign r minus x. So for the next 3 bits which are meant for the group, I am assigning r minus x. Clear? Again more examples. In my previous slide I had explained that we can convert this particular RWX series into a set of decimal numbers, right? So first 3 bits, okay, if that bit is set, I am giving it a value 1. If that bit is not set, I am giving it a value 0. Okay, so what am I saying here? I am saying change mod 755 to this file, meaning assign 755 as permissions to test file. So 7 means 111. So 7 in decimal means binary 111. 5 in decimal means 101. Again 5 in decimal means 101. So when we say chmod 755 to this file, we get these permissions. That means the owner of the file have read, write, execute. Group to which the owner belongs have read and execute, and any other user on the Linux file system have read and execute permissions to this file. Clear? One more example. Here I am assigning a permission 743. So 7 means 111, 4 means 100, 3 means 011. So what does this mean? Owner of the file have read, write, execute. Group to which the owner belongs just have read permissions. It doesn't have write, it doesn't have execute. And last 3 bits are for any other user. It has only write and execute permissions. It don't have the read permissions to this file. Clear? One more example. Here I am giving a permission 043. 0 means, so 0 in decimal means in binary 000, 4 meaning 100, 3 meaning 011. This permission means the owner of the file don't have any permissions, because the first 3 bits are 000. The group to which the owner belongs just have read permissions. It don't have write, it don't have execute. And any other user on the file system just have write and execute permissions to this file. It don't have the read permissions. Clear? So these are some examples of chmod, so using which we can change the permissions of the file on your Linux file system based on whether you want the owner to have read, write, execute, a group to have read, write, execute, or any other user to have a read, write, execute. Clear? So next command that we have is chgroup. It changes the group of the given file to a special group. Okay, so suppose you want to change the group to which that file belongs to some other group, then the command is chgroup. So I am assigning the test files group to new group whose name is special. I repeat, I am assigning the group of the test file to a new group whose name is special. Clear? Some more examples on the commands. Suppose I want to list all the files in my current directory which were created in month of August. So ls-l will list all the files in my current directory, and to that I am doing a grep operation with a string aug, August. So the entire output of ls-l will be given to the grep command, and grep command will only filter out the entries having a pattern aug in that. If you just notice carefully, all the lines have aug in that. So only the entries having a aug in that will be listed. There is one more command called sort, and food is the name of a file which has lots of entries in it. So the sort command will sort the entries in so and so file in alphabetical order and display it on the screen. So A comes before B. So this is the order. Clear? Some more commands. iwconfig is a command for getting the wireless configuration information. Okay, with that we are ending the commands, a simple commands that we used in Linux operating system. Now we will start with the shell scripting. Okay, so in shell scripting, the very first line that we mention is given a name called shebang, which tells which shell to use. Okay, so hash exclamation sign slash bin slash bash, meaning I'm using a bash shell for this particular scripting. Okay, and it needs to be written exactly the same way without any spaces. So this needs to be a first line in your shell scripting. Echo is a construct used in shell scripting to display the text to the user. So echo hello world will display hello world on the screen. Okay, I repeat, echo is an entity or a construct which is used to display the text to the user on the screen. So in your bash script, suppose you type echo and hello world, it will display hello world on your screen. So this is the first program that you all can try out on your Linux machine. Just add these two lines. So I would like to request you all that as and when I explain different shell scripting terminologies, I have given simple programs here in my sessions. Please try them out, so you will get more understanding of what I am speaking. Okay, so this is your first script. Give shebang and say echo hello world. Just try out this script. It will print hello world on your screen. Clear? After you write this script, what I have done here is, you will be writing this script in a particular user, right? You will be logging into your Linux system in a particular user. You will have your username and password. See, so once you log in into your system, you will write this program. Now you need to have execute permissions to your file in order to execute it. So let's do that. We have already seen a command in my previous slide to give permissions to a file. And what is that command? chmod. So you need to have execute permissions to your file in order to execute this, right? So I am doing exactly the same here. I am doing chmod and I am adding execute permissions to all. Okay, so I am giving execute permissions to all user. With this, it gives execute permissions to everyone. A is for all. Suppose you want to give read write execute permissions only to the owner of the file. How to do that? Simple. The first 3 bits are meant for owner, and if I want to give read, write and execute permissions only to the owner, then first 3 bit needs to be set. So 3 ones in binary mean 3 ones in binary, if you convert it to decimal, it means value 7, right? So I want to give read, write and execute only to the owner of the file. That means the first 3 bits are set to 1, which is a value 7. And I don't want to give any permissions to any other user in the group and any other user on your file system. So other bits are set to zeros. So 7, 0, 0. Clear? So again I'll repeat, if you want to give execute permissions to all the users on your Linux system, then please do A plus X. A is all the users, and I'm adding execute permissions to all the users on your Linux for this particular file. Suppose you want to give read, write and execute permissions only to the owner, then first 3 bits need to be set, and 111 converted to decimal is value 7. So 7, and I don't want to give any other permissions to any other users on your group and any other users on your Linux machine. That's why remaining 6 bits are set to 0, which converted to decimal is 0, right? So when I do chmod 700 to this file, it means it will give read, write, execute only to the owner. Now that I have written a simple hello world program, I've given execute permissions to it. Now let's see how to execute that file. You have to go to the current directory where this particular file has been written, and then there are two ways you can execute this. Either give /filename, that means it will execute this particular shell script, or you can type bash followed by file name. So bash space file name, it will execute that. So these are the two ways in which you can execute. Either go to that particular folder where you have written this file and do /file name, or do bash file name. So pwd is a command to print the working directory. So it will print the current directory, and suppose you have created this file in this directory, just do /file name to execute that file. Clear? In the very first program that we have written, we just echoed hello world on the screen. Now I want to explain to you all some advanced version of echo. So in the previous program we just did echo hello world, so it printed hello world on the screen. Now let's see what are the advanced features that this echo has, which we can use while printing. So for echo command, if you want to interpret following escaped characters in the strings, how to do that? To that echo you have to pass -e switch. So if you pass -e to echo, it interprets all these escaped characters in the string. So inside that, suppose if you have /a, it will alert with a bell sound when the script is executed. If you have /b inside that string, it will print a backspace in the output. If you have /c, it will suppress the trailing new line which normally gets displayed. If you have /n, it will print a new line character. If you have /r, it will have a carriage return printed. If you have /t, it will print a horizontal tab in the output. And suppose if you have two slashes, it will print one backslash. One is meant for escaping, and second backslash it will print on the screen. So when you pass -e switch to echo, it can understand any of these escaped characters in your string. So let's have a simple example. So this is another script, okay? Clear will clear the screen, your output screen. So any contents, if it is displayed, it will clear that off. Now there are system defined different variables on your Linux. So $user, capital letter user, will print your username. Okay, so I am doing echo hello $user. $user is a system defined variable, okay, which will contain the user who have logged in into your system. So this is your username. So echo hello $user will print on the screen hello and the username, which is your name. In the next echo, I am giving -e, that means it will interpret for any escaped characters which are given in the string. So what's that? So it will understand the meaning of /c. So what /c does? /c will suppress printing of the trailing new line character. So I'll explain to you all this /c by not having it and having it. Suppose let's take an example in which I don't have this /c here at all. So what I have on my screen is today is space semicolon and a date. Semicolon is meant for executing multiple commands on a single line. So normally what happens is it will print on the screen today is, and it will print a new line character, and then it will print a date for you. But I don't want that date to come on a new line. For that reason I am saying use /c. So /c will suppress printing of that trailing line. So when I do this, it will print on the screen today is and the date on one line itself. Okay, what this statement will do is, again I have given -e, that means it will interpret /c, so it won't print the trailing new line. So it will print on the screen number of user login. So how to find how many users are logged in into your Linux machine? So who is the command? When you type who, it will print the details of all the users who are logged in into your system. So to that I am piping wc-l. wc-l means please count the number of lines, okay, in the input that has been given to it. So who will give the details of all the users who are logged in into your system with one line per user. So suppose you have 3 users logged in, who command will print 3 different lines giving details of all 3 users. So that we are piping to wc-l, will count the number of lines that it has gotten. So it will print 3. So if I combine both this, what it will print on the screen is number of user login 3. Because you have used /c, it won't print the trailing new line character which normally gets printed. Okay. Next is I am doing echo calendar /c. Here also we are suppressing printing of new line and we are calling cal. Cal is a calendar utility which will display the calendar on the screen. So this /c will again prevent printing of the trailing line, new line. So it will print calendar followed by the calendar, and then we are exiting the script. So here I have shown the output of this script for you to make it more easy. So first line says hello and username. So it prints hello Viraj for me. Next is it prints today is so and so date. So today is so and so date. Then it prints number of user login. Number of user login 2 because there are 2 users on my system who are logged in. Then it prints echo calendar followed by the calendar. So it prints calendar followed by the calendar. And then I am exiting the script. So this is the output that this script will generate when you try it out. So please try out this script. Remember the first line of this script needs to be shebang, which is this hash exclamation /bin/bash followed by your code of the shell scripting. So please have this as a first line in all your shell scripts that I have given. So I won't have to repeat this line in every of my examples, right? So please have this as your first line followed by my code. So please type this code. After that first line you will get this output. Okay. Then we'll move on to next concept in shell scripting called shell arithmetic. We can perform arithmetic operations in your shell scripting. So expr is a command for expressions and evaluating those expressions. So expr 1 plus 3, meaning it will add 1 plus 3, it will add 1 and 3, and expr 1 plus 3 will output 4. So we can add, we can subtract, divide, modulus, multiply. Okay. So expr means evaluate the expression followed by the expression. Please remember that you need to have proper spaces between the operators and operands, just like the way I have given on the screen. We cannot have expr 1 plus 3. You need to have a space between the operator and operands. So please type it exactly the way I have given here. So expr 2 minus 1 will print value 1. expr 10 divided by 2 will have 5. expr 20 modulus 3. Modulus 3 is the remainder. So you're dividing 20 by 3, remainder is 2, so it will give you value 2, and in this expression I'm multiplying 3 with 10, so 30, and I'm escaping it with slash, because asterisk is a special character in shell scripting. So here I'm doing echo, and if you notice carefully here, I've used one letter from the keyboard here. Okay, so with this it will execute this particular expression. So this particular character in your shell scripting means execute so and so command in its subshell. So if you want to execute any command in your bash scripting, you definitely need to have it in this enclosed inside this character. So I am saying expr 6 plus 3. So it will have a value 9 echoed. So that means it will print 9 on the screen. Suppose you don't have, suppose you just type echo expr 6 plus 3, it won't evaluate the expression 6 plus 3, but it will just print this as if it is just a string. So just try echo without embedding this expression in these characters. It will echo expr 6 plus 3 on the screen. It won't evaluate 6 plus 3 to 9. For that, for any evaluation of any command in shell scripting, please enclose it between these characters. Okay. So I've recorded many lectures on shell scripting which are coming up ahead. So to get access to all the lecture series, please email me at virajonlinetutor@gmail.com. So please email me at virajonlinetutor@gmail.com for all the lectures on shell scripting coming up ahead. Thank you.